In these questions, we're going to be looking at how we link azimuth and hour angle. So the hour angle of Aldebaran is 1 hour 10 minutes. Deduce the approximate azimuth of Aldebaran at this moment. So we're assuming that we're looking south here. So if we're looking south, obviously we're looking at 180 degrees, which is south. And we know that the hour angle is 1 hour and 10 minutes, which means it's moved past. Now we also know that 1 hour is equivalent to 15 degrees of movement approximately, using the fact that there's 360 degrees to go around 24 hours. So 1 hour is 60 minutes, and we want to work out what 1 hour 10 minutes would be. So on top of our 60 minutes we need another 10 minutes. So how do we go from 60 to 10? Well, we divide by 6. So we're going to do the same on this side, which gives us 2.5 degrees. So we know that 10 minutes is 2.5 degrees. So 1 hour 10 minutes will be the 15 degrees plus 2.5, which is 17.5 degrees. Now, because the hour angle is positive, we know therefore that the star has already passed the meridian and is now moving to setting. So therefore we know that it will be moving towards the west. So it's 180 degrees plus the 17.5 degrees, which will mean that it has an azimuth of approximately 197.5 degrees. So at a particular moment, the hour angle of Sirius is 20 minutes. Deduce the approximate azimuth of Sirius. So again, we're going to assume that the meridian facing south was 180 degrees and that it has passed us. It's now 20 minutes past. Again, we know that 60 minutes was equivalent to 15 degrees, but we haven't got 60 minutes, we've got 20. So to go from 60 to 20, we divide by 3. So doing the same on this side, there is a difference of 5 degrees. So therefore we know it's 5 degrees further. So 180 plus the 5 degrees gives us an azimuth of 185 degrees. So the hour angle for Castor is minus 1 hour 12 minutes. So again, we're going to work this out in a very similar way. We know that 180 degrees was our south, but this time because it's negative, that means that the star hasn't yet reached culmination, hasn't yet passed the meridian, and it's coming towards it. So again, we need to work out what 1 hour and 12 minutes would be. So we know the same fact that we're using, that 60 minutes is the same as 15 degrees, but we don't have that. We have 72 minutes because we've got 1 hour plus 12. So what do we need to do to go from 60 to 72? We times by 1.2. So we're going to do exactly the same on this side. Multiplying it by 1.2 gives us 18. So therefore we know that it is 18 degrees earlier than 180. So we're going to do 180 minus 18 degrees, which gives us an azimuth of 162 degrees. At a given moment, the azimuth of a star is 186 degrees. Calculate the approximate value for the hour angle of the star. So we know that culmination point would be 180 degrees. We know that it's 186 degrees, which means it's already past culmination. It's on its way to setting. Therefore, we know that the difference between these is 6 degrees here. So using what we've been using before, that 60 minutes is equivalent to 15 degrees. We want to work out what 6 degrees is. So how do we get from 15 to 6? We divide by 2.5. So we'll do the same on this side. 60 divided by 2.5 gives us 24. So we know that it is 24 minutes past the hour angle, and that will of course be positive because it is already past culmination. Okay, at a given moment, the azimuth of a star is 170 degrees. Calculate the approximate value for the hour angle of the star. So for this one, we know that that would be 180 degrees, and we know that it's somewhere over 170 degrees. So we want to work out the difference between it here for our hour angle. So we know that the difference is 10 degrees. So our degrees is 10. and we remember that, what do we remember? We remember that 60 minutes is the equivalent to 15 degrees, and we want to go from 15 to 10, so we're going to divide by 1.5. So we will do exactly the same on this side, so that gives us 40 minutes. So therefore we know that it is 40 minutes for the hour angle, and because it is earlier, it will be minus 40 minutes, as it is yet to pass culmination. In 6, Hassan observes algenib when its azimuth is 192 degrees. If the right ascension of algenib is 3 hours 24 minutes, deduce the local sidereal time where Hassan is carrying out his observations. So how will we do this one? Well, we know that his meridian would be 180 degrees, and we know that the star that he's looking at is at 192 degrees, and that is algenib. So we want to work out the difference between here and here. So this is 12 degrees, the difference between them. So again, we can work that out into time by using 60 minutes is the equivalent of 15 degrees. So we need 12 degrees. So how do we go from 15 to 12? We divide by 1.25. So we're going to do the same on this side. Dividing by 1.25 gives us 48 minutes. Now we know that the right ascension of algenib is 3 hours 24 minutes, and that star is here. So we want to know what the right ascension is, therefore, of a star that would be on our meridian. So we know it will be 48 minutes later than algenib, because that's our difference. So we're going to add 48 minutes onto 3 hours and 24. So if we go up to the hour, there's 36 minutes to 4 hours, and then we've got 12 minutes left over. So it'll be 4 hours and 12 minutes. And that will be the local sidereal time, because the local sidereal time is equal to the right ascension of a star upon your meridian. Tricky one. Hopefully we did it. And 7, an astronomer observes Gamma Gem when it crosses his meridian at 6:38 local sidereal time. What will the approximate azimuth of that star be at 7:14? So again, if we think about how we're drawing it, the astronomer observed the star when it crossed the meridian at 06:38. We want to know the approximate azimuth, where it will be at 07:14. So again, we want to find out how much time has passed between 6:38 in the morning and 7:14, which is 0 hours and 36 minutes. We can then work out the difference between them. Again, we're going to use our same conversion we've been using the whole time. That 60 minutes is equivalent to 15 degrees. This time we are looking at 36 minutes. So what do we do to go from 60 to 36? We divide by, what do we divide by? 1.6. So we're going to do the same thing to 15. 1.6 recurring gives us 9. So therefore we know that it is 9 degrees further forward. So if this was 180, 9 degrees further would give us an azimuth of 189 degrees. So again, some tricky ones there. Hopefully you got on top of them and try the Kahoot. So good luck with that.